Before going into multiplication, which is the last part of simple operations, I just want to go through certain important concept of two things. The concept of Kronecker delta and Levi Civita. Alright? And therefore, if you remember, I have a directional vector, alright, directional indications, alright, I would say that. And then I have a basis vector. If you still remember back in our old videos, we have E3, E2, and E1 hat. Alright, these are all the unit vectors. And these unit vectors, as we call, can be called as EI in this I vector space. Alright, these are the basis vector. Alright, with a hat. Okay, and in another, alright, in another space, perhaps we have some tilting, alright, in another space. We have another, alright, maybe in a different color right now. We have another basis vector, E3, E2, E1, alright, hat. So the another basis vector has another configurations of, another configuration, as to say, has another set of basis vector, alright, and I can call this J, alright. So in other words, I can call this thing is equals to E hat J. Okay, now, alright, now comes the very important understanding. I'll not go to the derivation of that, just the understanding of that is, if EI, alright, is dot with EJ, if EI hat is dot with EJ, this means that this set of basis vector, when dot with this set of basis vector, is gonna give you a Kronecker IJ, or the Kronecker delta function. Okay, in some sense, if you were to take a look in terms of I is equals to J, when I is equals to J, the Kronecker IJ is equals to 1. Alright, if I is not equals to J, then Kronecker IJ is equals to 0. So if you remember that dot product, if it's equals to 0, this means that two vectors are perpendicular to each other. Alright, so if delta ij is equals to 0, this means a certain components, or certain, I will call it the basis now, a certain basis, right, is perpendicular to, a certain basis in the I space is perpendicular to a certain basis in the J space. Alright, this is the meaning of that. Alright, and then if it's perpendicular. If it's parallel, alright, if certain basis in the I space is parallel to the certain basis in the E2, alright, so for example, if E1, alright, for some reason is perpendicular to this E2, alright, if they are like if they are parallel, right, if happen that they are line parallel, this means that delta ij is equals to 1, alright, because the degree itself, if you remember, cosine 0 is equals to 1, meaning the angles between the two vectors are zeros. Okay, I just don't want to confuse you anything, but just to introduce the Kronecker delta in a more definite way. So just to let you know, EI dot with EJ gives you a Kronecker delta IJ with this set of parametric understanding. Alright, and it is also corresponding to the identity matrix. Okay, this is the full meaning of the Kronecker delta, and the understanding for this is very important. I highly recommend you just memorize it. Okay. On the other hand, on Levi Civita, is gonna talk about something deals with a cross product. Alright, this equals to the epsilon ijk a, j, and bk. Alright, I will not go into details on how to do this, right? But it's in your book, so you can just check it out. Alright, it's a book of page 130. Alright, if you want to go and check it out. Alright, so the definitions of the key understanding of the Levi Civita, it goes like this. Alright, it is this. Alright, 1 if ijk it's clockwise. If it's ijk anti-clockwise, then it's minus 1. 0 if ij are equals, or I and k are equals, or if 3 of them are all equals, then it becomes 0. Alright, so exactly what does this mean and how this is being applied into cross product, I'll not go through that, but in terms of the definitions and how to apply, I'll try to do it up over here. And by writing all these things, alright, this is one part of the cross product using the Levi Civita thing. So this is not the full cross product proof, but this is just an application on how the Levi Civita is being applied. So I'm not going to prove to you how cross product is being derived over here. I'm going to only tell you how to apply this Levi Civita. Okay, so it's pretty straightforward. Is that if ijk is clockwise, in this case 311 is neither clockwise or anti-clockwise. It falls under this section. So in this case, jk, alright, j and k are the same, so it's 1 1, right? And therefore this whole thing becomes 0. Alright, now E321 in this case is from 3 to 2 to 1. Alright, it's going in the anti-clockwise direction. Alright, it's going in the opposite directions. 3 2 1. Therefore I can say that this is minus u2 b2 b1 because it's anti-clockwise, right? Anti-clockwise, then you put as minus 1. So this is somewhat of an operation on the operator itself. Alright, and then E331, in this case it's I and K are the same, right? I and J are the same, sorry, so therefore it's 0. So in other words, if one number appears twice, like this says 3333 and 33 over here, everything goes to 0. So you know that this is 0, this is also 0, 322 is 0, this is also 0, 313 is 0, 312 is 0. And therefore at the end of the day, we can only achieve minus u2v1. Alright, okay, sorry, it shouldn't end there. If you take a look, now we have a 312 in this case, right? So 312 in this case, what it is, you may feel tempting to write in terms of anti-clockwise, but take a look. If I have 1 2 3, alright, and then it goes back to 1, it's actually a clockwise direction. Alright, if it's for example the 3 to 1 case, right, it's 3 2 1, so it's going in the anti-clockwise direction. Right, you see 3 to 1, alright, in this case is actually a clockwise. So in this case this is actually a clockwise, and therefore this is 1. So be very careful of knowing that there is if two values are the same, becomes 0, but when you cancel, be very careful of looking out for those that are not to be cancelled, which I actually did some careless mistake over here. So in this case, I can just say that I have minus u2v1 over here, and then in this section I have E312 is a clockwise direction, so it's 1. So I'll just simply write this as u1v2, and then this is 0. And if I were to write in terms of the representation of a summation, I can simply write as minus u2v1 plus u1v2. Okay, so this is this portion states a certain vector. This portion states a certain vector. So you sum out all the directions. That is what it's trying to say. Alright, and therefore, as I say, this is only one small portion of the cross product, right? But just want to apply to you and show you the Levi Civita, how it is being applied, and what is the meaning of the clockwise and anti-clockwise. I hope this is pretty clear, and therefore I believe we are ready to go to this section. I will see you there.